MAP4C 5.4 quadratic models. So what we're going to do is investigate what do quadratic relations look like in the form of a table of values, a graph, and an equation. So let's start with the table of values. In a table of values, we can determine if the relation is a quadratic relation if the second differences are equal. So we saw earlier that a first differences test determines whether or not a relation is linear by taking the adjacent points, y2 minus y1, and comparing these differences. In this case, we can see that the differences are not equal, and therefore it is non-linear. But we can go a step further to take the second differences, which is the difference of the first differences. So negative 36 minus negative 12. Notice minus negative 12, we can rewrite this operation as negative 36 plus 12. So we see that these are equal in value, so therefore the second differences being equal implies that the relation is quadratic. In our second example, the first differences were different, so it's nonlinear, and the second differences are different, so therefore it is not quadratic. So, as a graph, the quadratic relation is a parabola. The parabola is referring to the actual curve itself. It's U-shaped and symmetrical. This image highlights some important features of the graph. The vertex, seen here on the image, is either the lowest point on a minimum, or if it were the other way, a maximum right here. And this can have important information for word problems or application problems. In an equation, all quadratic relations are degree 2. The degree of a polynomial expression is the highest exponent on the variable x. So there are the three different forms that we learned previously: standard form, factored form, and vertex form. Each reveals different information. In standard form, the only characteristic that we know is that the y-intercept is c. In factored form, this allows us to find the x-intercepts. And vertex form tells you where the vertex is located with coordinates hk. So, in order to be able to look at an equation by inspection and determine whether or not it is quadratic, we said we are looking for a degree 2 polynomial. So that means that the exponent on x is 2. So in this case here, this term, remember terms are separated by addition and subtraction, there's two terms here. In the first term, the power, or the exponent, is 2, so it's quadratic. In this case here, this term has no exponent written, but we assume that's equal to 1. And a degree 1 polynomial is linear. This is not quadratic. We will get around to this right here. This does not have a base of x. This has a base of 2 to the power x. So that is not a quadratic relation. This, we will see, is an exponential relationship. And lastly, this one's challenging. We have a degree 1 here, a degree 1 here. But remember, this is a different form. This is factored form. And if we were to multiply this binomial, two terms, times this binomial, we would use FOIL. For x times x being our first, being multiplied would be x squared. So it's a little bit tricky, but it is quadratic.